Good day everyone. In this video, I will going to discuss about clock problem. So by the end of this lesson, you will be able to apply the concepts in algebra in solving clock problems. So this is the concept in analyzing a clock problem. Now as you can see here, this is our analog clock. So in our analog clock, we have three hands: the minute hand, the hour hand, and the second hand. But for our problem, we're going to focus only the two hands, the minute and the hour. So for a typical problem, we are going to track the number of minutes that is being covered by these two hands, the minute and the hour. So for the minute hand, we all know that in 1 hour, it can cover 60 minutes. Now, if we're going to visualize this one, let's say, for example, the time now is 1 o'clock. So to visualize that one, our minute hand is positioned at the number 12, and then our hour hand is positioned that is pointing to the number 1. So this is our 1 o'clock. So in 1 hour, this minute hand will cover a one complete revolution of our analog clock, and that is equal to 60 minutes. Whereas for our hour hand, in 1 hour, it can only travel from number 1 towards or up to number 2. And if we're going to measure that one, that is only equal to 5 minutes. 5 minutes. So therefore, if the minute hand uh, travels x minutes, so here it is. Now the question is, uh, what is the speed of the hour hand relative to the minute hand? So we're going to use ratio and proportion. That is, if the minute hand travels x minute, what would be uh, the number of minutes that is being covered by the hour hand? So let's represent that one by y. So that will be equal to the number of minutes traveled by these two hands for 1 hour. So for the minute hand, that is 60 minutes. Then for the hour hand, that is equal to 5 minutes. So we're going to solve for y here in terms of x. So we do cross multiplication. So that will be y is equal to 5x over 60. And if we're going to simplify this one, that is equal to x over 12. So this is the number of minutes that is being covered by the hour hand in terms of the minute hand. So if we're going to visualize uh, these variables on our analog clock, so we're going to erase this one first. Say for example, the time is 3 o'clock. So the position of our minute hand is pointing to the number 12, and then our hand is pointing to the number 3. So this is our 3 o'clock. So if our minute hand covers, let's say, x minute, so this is our x automatic. The hour hand covers this one. This is equal to x over 12. So that's it. We are going to use um, this expression in order to analyze clock problem. So this is how you're going to analyze clock problems. So the typical questions for clock problems, we have the time, the minute and hour hands come together. So if we're going to visualize that one, uh, the both the minute hand and the hour hand will coincide with each other, or it could be opposite to each other. So just like this one, let's say if this is our minute hand, so this is our hour hand, so they are opposite to each other. Or there are some cases that these two hands will be at right angles to each other. So these are the typical questions from the clock problems. Now we have here a shortcut in solving the time. So um, instead of illustrating the problem, you can use this shortcut formula. But this formula does not apply to all clock problems. So this one is only um, limited to simple clock problems. So we have here the time t is equals to 60 over 11y. So what is the what is the meaning of the variable y here? So the variable y is the number that comes before the minute hand. This is the number in our analog clock that comes before the minute hand. Let's say, for example, let's go back here to our analog clock. So if the time now is, let's say, um, 2 o'clock, and then the question is, if the minute hand travels, let's say, an x distance, like somewhere between 1 and 2, and of course our hand will also cover a distance of x over 12. So instead of um, illustrating the problem and trying to generate a working equation, so you can use the shortcut by tracking the final position of our minute hand. So in this um, figure, the final position of our minute hand is between 1 and 2. And the number that comes before the minute hand is the number 1. So you're going to multiply 1 to 60 over 11 to get the time. That's it. So that is how you're going to use this shortcut formula. Or let's have another example. Let's say the uh, minute hand falls between numbers 5 and 6, and then our hand is between 8 and 9. So the time here is 8 8 o'clock, and we don't know the number of minutes. So in order to predict the number of minutes after 8 o'clock, so you're going to track the final position of our minute hand after 8 o'clock, and that is between 5 and 6. So our y here is the number that comes before the minute hand. So that would be the number 5. So you're going to multiply 5 by 60 over 11 to get the number of minutes after 8 o'clock. And that would be the exact time. Okay? So we have here a trivia. Sorry. uh, it is being covered by my solution. So we're going to erase this one. As you can see, there's a trivia for our clock problem that the minute hand and the hour hand meet together 22 times per day, not 23 and not 24. So try to explore it by yourself. Okay, so let's have our first problem. So the problem states that at what time between 4 and 5 o'clock will the hands of the clock be coincident? So the answer is 4 o'clock and 21.82 minutes. So first things first, for a clock problem, let's try the long method in which we are going to um, illustrate the problem. So from the problem, it is stated that between 4 and 5 o'clock. So we are going to illustrate first the initial position of our clock. So that would be at 4 o'clock. So the 4 o'clock is like this. So the position of the minute hand is at 12, and then the hour hand points at 4. Okay, so uh, your hint in illustrating the final position is this word right here. So coincident, meaning at some point of time after 4 o'clock, both the minute hand and the hour hand coincides together. So of course they will coincide between 4 and 5, not beyond 5, because the hour hand is only uh, restricted to move between 4 and 5. So it will not move beyond 5. So therefore, they will intersect between 4 and 5. So let's draw their final position. So we're going to use another color. So this will be our hand, and this will be our minute hand. Okay. So um, we are going to measure the number of minutes that is being covered by our minute hand. So our minute hand starts from 12, and then again it covers x distance. Okay, so we don't know this one, so this is our unknown. And then the next one is that we're going to measure also the distance that is being covered by our hand. So our hand moves from um 4 towards the final position. So the distance for this one, again in terms of x, we already derived this one. So that the number of minutes that is being accumulated by our hand in terms of the minute hand is equal to x over 12. Okay, so that's it. Now the number of minutes from 12 to 4, that is equal to, again, from 12 to 1, that is 5 minutes, 1 to 2 another 5 minutes, 2 to 3 another 5 minutes, and then 3 to 4 is another 5 minutes. So we have 5, 10, 15, 20. So from 12 up to the number 4, so the number of minutes is 20. Okay, so from our illustration we can generate a working equation. So our working equation is equal to, again, the distance from 12 up to the final position of these two hands is equal to x, right? And then this is also equal to the distance from 12 to 4, and that is 20 minutes. So that is 20 plus the distance covered by the hour hand from number 4 to the final position. So that would be x over 12. Then after that, um, solve for x. So to eliminate the fraction, you can multiply both sides of the equation by 12. So you have 12x is equal to, this one is 0, 4 to 40 plus x. Then transpose x to the left side. So you have 11x is equals to 240. Then divide both sides by 11. So our x is roughly 21, 21.82 minutes. So therefore, the time is 4 and 21.82. Okay, so this is our final answer, and this one is correct. Now, um, this is the long method, but you can also solve this problem by using the shortcut formula. Shortcut formula. So our shortcut formula in solving the time after 4 o'clock, in which the two hands will coincide with each other, is by using this one. So t is equals to 60 over 11 y. So our y is the number that comes before the minute hand. So again, I already told you from the previous slide that you need to keep track the final position of our minute hand. So in our illustration, the final position of our minute hand is between 4 and 5. So the number that comes before the minute hand is the number 4. So our y is equals to 4. So simply multiply 60 over 11 by 4. And that is roughly equal to 21.82 minutes. So the time is 4 o'clock and 21.82 minutes, which is the same with the long method. Now let's try this one. So for our problem number 2, the time is 3 o'clock and the hands of the clock are at right angles to each other. So the question is, what is the nearest time of the clock such that the hands of it will be at right angles again? The answer is after 32.72 minutes. So for our clock problem, it is preferable to um, to illustrate the problem. So the problem starts at 3 o'clock. So the position of our minute hand points at 12, and then our hour hand points at 3. So by visual inspection, both the hands, they are at right angles to each other. So the final position will be uh, the time in which these two hands will be at right angles again. So again, um, we are going to analyze this one. So the movement of our hand is only limited between um, 3 and 4. So we need to rotate the minute hand first, such that um, these two hands will be at right angles again. So um, please take note this one. No? For right angle, the number of minutes for a right angle is equal to 15 minutes. So notice this is our right angle. This is 90 degrees. So the equivalent of this angle in terms of minutes is equal to 5, 10, 15. So for a right angle, and that is equal to 90 degrees, that is also equal to 15 minutes. Okay, so um, let's illustrate first the final position of our R hand. So we all know that the R hand is only restricted between 3 and 4. So let's assume that the final position of our R hand is somewhere between 3 and 4. Now, let's count uh, 15 minutes from this position in order to get the final position of our um, minute hand. So that would be between 3 and 4 to somewhere between 4 and 5. That is 5 minutes. Then right here, 10 minutes. Then right here, 15 minutes. So this is probably the position, the final position of our minute hand. So the angle between the hour hand and the minute hand in this position is again equal to 90 degrees. Okay, so we are going to uh, add some measurements. So let's start with the minute hand. So after 3 o'clock, the minute hand covers an x distance. So we're going to draw that one. So this is our x distance. Okay, so this is also the requirement of the problem. Next, uh, the measurement of uh, this one, okay, from 12 to 3, we all know that this one right here is equal to 15 minutes. Okay, we all know that one. And then the measurement from 3 up to the final position of our hand. Again, this is um, the number of minutes that is being covered by the R hand, and that would be x over 12. Okay, then the distance from the final position of our R hand and the final position of our minute hand is also equal to 15 minutes because that is uh, equal to 90 degrees. Okay, so I guess um, our illustration is already complete. So next is we're going to generate our working equation out from this illustration. So as you notice, the distance from 12 up to the final position of our um, minute hand is equal to x. So write x. And then this distance is also equal to the sum of these small distances. So what are these small distances? So we have the 15 minutes plus the distance covered by our hand, that is x over 12, this one. And then the last one is the distance from the final position of our hour hand and the minute hand, and that is equal to 15 because it is also stated in the problem that what will be the time, that these two hands will be at right angles again. So we have here 15 minutes. Next, um, we're going to simplify this equation to solve for x. So that would be x over 12 plus 30. Then multiply both sides by 12 in order to eliminate the fraction. So you have 12x is equal to x plus 30. Then transpose this one, it will become 11x is equals to 30. Then divide both sides by 11. So x, sorry, I forgot to multiply um 12 by 30. Okay, so I think we need to erase this one also. Okay, so 30 multiplied by 12, that would be 0, 3 times 2, 6, 360. Okay, so this one should be 360. So 360 divide by 11, that would be approximately equal to 32.73 minutes. Okay, and this one is uh, very close to our answer right here, which is 32.72 minutes. Okay, so this is how you're going to solve this problem using the long method. Now let's try the shortcut formula. Let's see if we can still use the shortcut formula. So the shortcut formula, we have t is equals to 60 over 11y. Okay, so in using the shortcut formula, make sure to determine the final position of our minute hand. So in our illustration, the final position of our minute hand is between 6 and 7. By the way, the good thing in utilizing the shortcut formula is that um, uh, it is not or you're not going to um, draw or plot the distances. Okay, you will not need this one anymore. Instead, you just illustrate the final position of the minute hand as as stated in the problem. Okay, so um, the final position of your minute hand depends upon the way on how you interpret the problem. So again, let's go back right here in our analog clock. So the final position of our minute hand is between 6 and 7. So our y is the number that comes before the final position of our minute hand, and that is 6. So we're going to multiply 60 over 11 by 6. That would be 360 over 11, and that is roughly equal to 32.73 minutes. So the answer for our shortcut formula matches the answer of our long method. Okay, so for the next video, I will going to discuss the digit problem. So that would be all. Thank you.